Hello everyone, and welcome. Today, we are going to explore a powerful scientific technique called Mössbauer Spectroscopy. It might sound intimidating, but at its core, it's a clever way to listen to the secrets hidden inside atomic nuclei. Think of it like tuning a radio to a very specific station. Atomic nuclei can absorb and re-emit high-energy light, called gamma rays, but only at an extremely precise energy, a phenomenon known as resonance. However, there's a big problem. When a nucleus emits a gamma ray, it recoils, much like a cannon recoils after firing a cannonball. This recoil steals a tiny bit of energy from the gamma ray. Similarly, the nucleus trying to absorb the gamma ray also recoils. This energy mismatch, caused by recoil on both ends, means the station is always slightly off-tune, and resonance can't happen. This is where the magic of the Mössbauer effect, discovered by Rudolf Mössbauer, comes into play. He realized that if you lock the emitting and absorbing atoms into a solid crystal lattice, the recoil isn't felt by the single nucleus but by the entire crystal. Because the crystal is immensely more massive than a single nucleus, the recoil energy is practically zero. This allows for recoilless emission and absorption, and suddenly, the gamma ray has the perfect energy for the target nucleus to absorb it. So, how does this become a spectroscopy? We use the Doppler effect. We take our gamma ray source and move it at very slow, controlled speeds either towards or away from our sample. This movement slightly changes the gamma ray's energy, effectively fine-tuning it. We then measure the number of gamma rays that pass through our sample. When the energy is just right for the nuclei in the sample to absorb them, we see a dip in the number of transmitted gamma rays. A plot of this gamma ray transmission versus the source's velocity is a Mössbauer spectrum. This spectrum is like a highly detailed fingerprint of the nucleus's immediate chemical and magnetic environment. It can tell us things like the oxidation state of an iron atom, the strength of internal magnetic fields, and the symmetry of the atom's surroundings. It's a vital tool in fields like geology for analyzing rocks and minerals, in chemistry for studying catalysts, and even in biology for examining the role of iron in proteins like hemoglobin. Thank you so much for watching this deep dive into Mössbauer spectroscopy. If you found this video interesting and learned something new, please show your appreciation by liking the video and subscribing. Your support is what allows us to continue making content like this. We'll see you in the next video.